In this video, we're just going to take a quick look at an alternate form of how to write down Green's theorem. So one of the first things we're going to think about is, well, we could write a vector field in the plane as a vector field in space by just adding in that third component as a component of 0. So we could just simply have f as mi plus nj plus 0k. So there's just a 0 component in the third piece. So then the thing I want to notice from that is we could instead then define the curl of f. And the reason we're doing this is you'll notice that in Green's theorem we have these partial derivatives that get subtracted from one another. And the curl did keep track of sort of partial derivatives of that vector field. So then the curl of f, which remember is that del crossed with f, is the ijk for the cross product. And then the components of the curl are really sort of just the operations of those partial derivatives. So the partial of x, the partial of y, and the partial of z. And then those will be operated on the components of f, which we're going to use as m, n, and 0. And all of this is in that determinant form. So then this would be the I times that partial of y of 0, which is just going to be 0, and then minus the partial of n with respect to z. And then we would do the j component next. So we would do a minus in the front. And then we'd have the partial of 0, which is going to be 0, and then minus the partial with respect to z of m. So those negatives will cancel, and we'll be left with the partial of m. Sorry for my awkward writing there. With respect to z. So that's the j component. And then the k component, we're going to end up with the partial with respect to x of n. Oops. Minus the partial with respect to y of m. Which notice this piece right here is the piece that we use in Green's theorem. So we use that little piece right there. So an alternate definition for Green's theorem is we could have that Green's theorem is the integral over c of f dr, which again, remember this is the alternate way instead of saying the, this is just that same as md x plus n dy. But ultimately then that's going to equal that double integral over r. We wanted this piece to be in there. So one of the ways that we could represent that, if we want a little way to remember it, is we could do the curl of f. But notice I don't want all of this. That part I don't want. So one of the things we could do then is we could dot that with just the vector k. And this would be because k, remember, is the vector 0, 0, 1. So that's going to take this first component and multiply it by 0, and the second component and multiply it by 0. So all we'll be left with is this third component. So a way to remember Green's theorem is to do the curl of f dotted with k. We just want that third component of the curl if we do add that third component of 0 on the z component, the k component of f.